Imagine standing on the surface of a world where the sun never rises. No dawn, no dusk, just eternal, crushing night. You look up, but there are no familiar constellations. Just the faint, ghostly band of the Milky Way stretching overhead. The temperature is stable, but confused. It's not absolute zero. There is heat here, pulsing from beneath your feet. These are rogue planets. Worlds that have been kicked out of their solar systems to wander the galaxy alone. For a long time, we assumed planets needed stars. That a world without a sun was just a frozen rock. But the data is coming in, and it's telling a different story. These orphans aren't rare anomalies. They might actually be the most common type of planet in the universe. There could be billions of them. And the wildest part? They might not be dead. Some of them could be carrying life through the dark. Let's back up. How do you lose a planet? Gravity is usually pretty possessive. Solar systems are born in violence. It's not a clockwork mechanism. It's a demolition derby. When a star forms, it's surrounded by a disk of dust and gas. Clumps form. Gravity starts pulling. Dozens of protoplanets emerge, all fighting for the same lanes of traffic. It's unstable. Eventually, they get too close. Massive gas giants swing by smaller rocky worlds. It's a gravitational slingshot. The big planet transfers momentum to the small one. The small planet speeds up. It hits escape velocity. It leaves the star's gravity well forever. It's not a gentle drift. It's an ejection. A world the size of Earth, thrown into the void at 30,000 miles per hour. Simulations suggest that for every solar system that survives, a few planets get sacrificed to the cold. Our own solar system might have done this. We may have had a fifth giant planet that Jupiter bullied into exile. But ejection isn't the only way to make a rogue. Some of them might never have had a star to begin with. Stars form when giant clouds of gas collapse under their own weight. But sometimes the cloud is too small. It collapses, but it never ignites. It doesn't have the mass to start nuclear fusion. It becomes a brown dwarf, or if it's smaller, a sub-brown dwarf. A gas giant sitting alone in the dark. The line between a planet and a failed star gets blurry here. Nature doesn't care about our definitions. So we have these billions of worlds drifting in the interstellar void. How do we find them? They don't reflect sunlight. They don't block a star's light. They are invisible to almost every telescope we have. We have to use a trick called gravitational microlensing. It's Einstein's theory of relativity in action. Mass warps space. Even a planet has enough gravity to bend the fabric of the universe slightly. If a rogue planet drifts perfectly in front of a distant star, it acts like a lens. The background star doesn't get blocked. It gets magnified. For a few hours or days, that star flares up. We watch millions of stars, waiting for that specific, brief spike in brightness. It's like looking for a glass marble rolling across a black tablecloth. By waiting for it to distort a candle flame miles away, and we've seen it multiple times. The spikes in data that confirm a massive object just passed by. The implications are staggering. If we've caught a few by chance, the statistical projection is huge. Some estimates suggest there are 2 rogue planets for every star in our galaxy. That's hundreds of billions of wanderers. A silent majority of worlds that we never see. But here is the question that keeps exobiologists awake. Could you live on one? Intuition says no. Without a sun, the The surface temperature should be near absolute zero. Atmospheres should freeze solid and snow out onto the surface. A dead nitrogen ice tomb. But planets are batteries. They form hot and they hold on to that heat for billions of years. Earth's core is as hot as the surface of the sun. That heat has to go somewhere. On a rogue planet, that geothermal energy slowly bleeds out to the surface. If the planet has a thin atmosphere, that heat escapes into space. The world freezes. But what if the atmosphere is thick? I'm talking about a hydrogen blanket. In the early solar system, hydrogen is everywhere. A rocky planet could grab a massive layer of it before getting kicked out. Hydrogen is a greenhouse gas. A super insulator. It traps that geothermal heat perfectly. It's called the Steppenwolf prediction. A rogue Earth with a thick hydrogen sky could keep water liquid on the surface forever. No sunlight needed, just the slow burn of radioactive decay in the core trapped by the air. Picture it. A pitch black ocean. The pressure is immense, but the water is warm. There's no photosynthesis, no plants, no eyes, because there's nothing to see. But life doesn't need light. It needs energy. We see that on Earth, at the bottom of our own oceans. Hydrothermal vents pump out chemical energy. Bacteria eat the chemistry. Crabs and worms eat the bacteria. A rogue planet could have global oceans, teeming with life that has never seen a star. Complex ecosystems clustered around volcanic vents, fed by the planet's own internal fire. If you stood on the surface, you wouldn't see the ocean. The atmosphere would be crushed into a dark, supercritical fog. You wouldn't detect any light, but you might hear the wind. The heat differentials would still drive weather. Storms of high-pressure hydrogen sweeping across a dark, liquid surface. It sounds alien, but in a way, it's safer than Earth. Solar systems are dangerous. Stars flare. Asteroids bombard you. Orbits shift. Eventually, our sun will expand and burn Earth to a crisp. A rogue planet doesn't have that problem. It has escaped the death of its parent. It's untethered from the violent life cycle of a star. If the internal heat holds out, a Steppenwolf planet could remain habitable for 10 billion years, longer than the life of most stars. A slow, steady, dark existence. There's another possibility. Not a hydrogen greenhouse, but an icy shell, like Jupiter's moon Europa, but scaled up. A rogue planet covered in 10 miles of ice. The ice acts as the insulator. Beneath it, the pressure and core heat maintain a global ocean, protected from the radiation of space by the ice, protected from the vacuum. We used to think the Goldilocks zone was a ring around a star. Not too hot, not too cold. Rogue planets break that rule. They carry their Goldilocks zone with them. They are self-contained spaceships. The hull is rock and ice. The engine is the core. This changes how we think about the spread of life in the galaxy. If life can start in the dark, then the interstellar void isn't a desert. It's a bridge. These planets are moving. They aren't stuck in orbits. They traverse the galaxy. Over billions of years, a rogue planet could travel from one side of the Milky Way to the other. It could pass through star-forming clouds. It could drift near other systems. This leads to the panspermia hypothesis on steroids. If a rogue planet gets hit by an asteroid, chunks of ice and rock fly off. If that debris carries microbes, the rogue planet becomes a seed ship. It's scattering biological material across thousands of light years, far more effectively than a fixed planet ever could. we might be looking for aliens in the wrong places. We focus on Earth-like twins orbiting sun-like stars. We look for radio signals and oxygen lines in the spectrum of light. But the most common life in the universe might be deep underwater, in the dark, traveling between the stars. Of course, the darkness has a downside. It's hard to do science without a sky. If intelligent life evolved there, they wouldn't know the universe exists. They would have no concept of stars, galaxies, or cosmology. Their universe would be the size of their world. They might drill up through the ice one day and breach the surface. Imagine that moment. Breaking through the crust and seeing, for the first time, the Milky Way. The realization that they aren't the whole universe. That they are just a speck in a cathedral of light. It would be the biggest religious and scientific shock imaginable. And there is one final, darker thought about rogue planets. The collision risk. Space is big. The odds of anything hitting anything are statistically zero. But zero feels different when there are billions of invisible bowling balls rolling around. It's unlikely a rogue planet will hit Earth. But it doesn't have to hit us to hurt us. It just has to get close. If a rogue planet passed through our solar system, gravity takes over. It could eject Earth. It could pull us out of our orbit and send us into the cold. We would become a rogue planet ourselves. The oceans would freeze. The atmosphere would fall as snow. Civilization would have to move underground, tapping geothermal power to survive. We would join the silent majority, wandering the dark, waiting for a star that never comes. Fortunately, our surveys suggest the solar system is clean. No massive intruders on the horizon. The fact that they are out there changes the feeling of looking up at the night sky. The darkness isn't empty. It's full, packed with worlds that have broken their chains. Some are dead rocks. Some are frozen gas giants. But somewhere, in the deep gap between the stars, something might be swimming in a warm, dark sea, oblivious to us, oblivious to the sun, and completely at home in the eternal night.